Okay, let's have f of x is 1 over x and g of x as x. Okay, in this case we know that the domain of f is r star or r minus 0, and the domain of g is just the whole set of real numbers. Okay, we wanna find, or first we wanna compose f circle g of x, which is by definition is f g of x. So anywhere you see x in f, you just plug g of x. So here f, that means g of x, and g of x is no, sorry, 1 over g of x, which is 1 over x. Okay, and here g circle fx is g f of x. Anywhere you see x in g, you just put f. So here we have f of x, and f of x is 1 over x. Okay, so here the domain of these two functions is r minus 0. Here is r minus 0. Okay, but that's not how we compute the domain. Okay, it's a coincidence that we have these two domains the same, and we can get the domain from f circle g and g circle f, and suddenly they are the same. To compute the domain for any two functions like f circle g, okay, we need to see the restriction on g, the domain, the values that would make the domain, and we check what they do in the domain of f. Okay, in another term, if we are trying to find the domain of f circle g, note this f and g here in general is a real value such that x is in domain of g and g of x is in domain of f. Okay, so in our case here, it happened that we get the domain from f circle g and g circle f. It's not true that when you compose f and g, or g and f, you get the domain from the composition. No, you get the domain from here, from this condition here. Okay, we will see when we have two functions. Let's say f of x is 1 over x, and g of x is x minus 1 over x minus 2. Okay, so when we compose, we have another function, and when we find the domain, it's different. Okay, let's find the domain. Here the domain is r minus 0, and here is r minus 2. So it's the set of whole numbers except 2. Here it's the set of whole numbers except 0. Okay, so let's compose. Let's say we want to find g circle f. By definition is g f of x. So anywhere in g we replace x by f of x, so we get g of 1 over x. So here we have 1 over x minus 1 over 1 over x minus 2, and we do a simple algebra. It's 1 minus x over x, 1 minus 2 x over x, and we do division, assuming that x is 0, so we get x minus 1 over 2x minus 1. So, but from here, if we want to find the domain of this function, which we called g circle f of x, so it's x minus 1 over 2x minus 1. So the domain here is r minus 1/2. Okay? But we missed something. We missed the 0 that we divided by. Okay? So when we did the division, we missed 0. Another key idea is that without doing all this computation, we can compute the domain using this formula. In this case, we want to find the domain of g circle f. So it's those values in R such that x is in the domain of f and f of x is in the domain of g. Okay? So x in R, we are looking for these values, x in the domain of f. So that means x is different from 0 because this is domain of f, and f of x, which is 1 over x, is gonna be in domain of g, which is that means it's different from 2. To be in the domain of g, that means it has to be different from 2. And these two conditions, they give us x is different from 0 and x is different from 1/2 by flipping here. So we don't get this domain by reading this one. We get the domain by the composition of the domains. So the domain here is r minus 0 and 1/2. Okay, so if we do domain blindly, if we compute the function and after that we find the domain, we're gonna make a mistake. So look here, the domain looks like 1/2. It's r minus 1/2, but here it's r minus 0 and 1/2. Okay, so the best way is to make sure that you compute the domain before you compute the function or you compute the composite. Okay, or there is another idea. So check the restrictions on the domain of f. So like here, f has a restriction. It's x minus 0 or x different from 0. And compute g of f of x. When you compute that, check the domain. So the domain has this value. It's x has to be different from 1/2. So we have these two conditions. X is different from 0 and x is different from 1/2.